Awesome. I see we're at 1 minute past the hour. So welcome everybody to this webinar, part of the Vlad Talks Tech series on the Bot Framework Composer, a game changer for bot development. My name is Vlad Catrinescu. I will be your host, and I'm joined today by the star of the show and good friend of mine, Stephan Bisser. How are you doing, Stephan?
I'm doing great. Thanks, Vlad.
Hey, thank you very much for taking the time for this presentation for the community. Uh,
Thanks for
just,
inviting me.
just some housekeeping rules before I give you the stage. This webinar will be recorded, so you will get the recording. Everybody who registered will get the recording by end of day tomorrow. So if you ever have to take a few minutes off, don't worry, you can come back to it after, as well as all of the resources such as the slides or any links shared during the presentation will be shared with you by end of day tomorrow. This is it for me. Stephan, I will let you take over. And I'm personally really interested myself as I've never used the bot framework composer. So I'm going to be learning a lot as well. It'll be really, really fun.
Yeah, let's hope so. Okay, thanks. So, yeah, my name is Stefan. I'm based in Austria. I'm from Austria, as you might hear from my accent. I'm working at a company called Solvium. We're doing consulting in the Office 365 and Azure space. Um, if you want to get in touch with me after the webinar, just follow my Twitter handle or visit my blog. Um, and if you want to have some further resources, just visit the link which is present on the bottom of the screen, bit.ly/learn minus two minus bot, where you can find all bot framework related resources at a glance. So let's start. And to set the stage a bit, I want to talk first about some Azure AI stuff. For the folks who might not know what Azure or what Microsoft actually offers in terms of artificial intelligence in their public cloud platform Azure, because they've they've brought up quite a huge set of services and solutions you can actually use. So starting from AI on infrastructure, meaning AI on data, like specific AI services within Cosmos DB, or even SQL databases, where you can actually enhance SQL database queries with machine learning algorithms, or as well AI on compute, meaning you got a lot of AI services which are targeting, let's say, heavy memory loaded solutions where you have your own virtual machine types called DSVMs. They usually have a quite a large amount of memory and CPU resources attached to those, so you can do basically the heavy lifting of data and machine learning algorithms and so on and so forth. What Microsoft actually also offers is they can integrate various deep learning frameworks within various Azure services. They have their own deep learning framework called Cognitive Toolkit, but you can also use any other deep learning framework you're familiar with, like TensorFlow or Caffe2 or what have you. On top of those AI on infrastructure and deep learning frameworks, there are certain services built which they call AI services, and I usually like to call them AI as a service, similar to what software as a service is to us, where you have services in the area of conversational AI with their bot framework, where they have trained services in form of cognitive services, which are basically just a set of APIs you can use to integrate certain intelligent services within your existing solutions, or you can even build your custom AI services using the Azure machine learning space, where you can actually create and provide certain machine learning algorithms which you have developed for various services on your own. And on top of that, you have a certain set of AI tools which you could use, like VS tools for machine learning, the Azure ML Workbench, but also if you look at Visual Studio or Visual Studio Code, you get a lot of services and third-party integrations which you can use in order to develop your favorite AI services in your favorite tool or management solution. We're focusing in today's webinar on those two types of services. First, the bot framework, and second of all, the cognitive service part, because this is kind of the conversational AI space we're talking about today. If you want to build a bot, you got to use those tools and services to actually make that work. And in terms of conversational AI, you can actually call conversational AI some kind of subfield of artificial intelligence, and the focus of conversational AI solutions or services or applications is purely to have a kind of conversation between humans and computers. And it should actually be possible to expose either existing or new software services through that conversational interface, meaning in the past we had like apps or web applications or websites where users could just do like clicking here and there on buttons or inputting text, and this kind of model now is a bit of in a change, because with that conversational AI approach, it should be possible to talk to services like we talk to another human being, and the service should actually understand us and then deliver the correct solution or the correct output you want the service actually to be delivering. Of course, that's a new UI paradigm, if you will, because that kind of changes the whole interaction between how users use certain tools or services and how users communicate with those services. So it's not about clicking only and inputting text only. It's about voice, it's about speech, it's about maybe images, and so on and so forth. And the interesting thing about this is you need to think a little bit broader than you've done in the past, because it can not only run in apps or in browsers, it can also run on IoT devices. Like every one of you who is familiar with the Amazon Alexa, this is just a device using certain bot capabilities to be able to understand the users and to deliver the correct output to those users in a kind of different way as they're used to when they use certain apps or websites right now. And one of those main features and main use cases, of course, are virtual assistants or bots, which could also act in a kind of proactive way and have some proactive capabilities attached to it, to make that use case a bit more broader and a bit more simpler for users to be using. What is conversational AI in the Microsoft area or in the Microsoft space? They have come up with a quite complex or quite sophisticated platform when it comes to conversational AI. So they have their own open source framework, which is called the Microsoft Bot Framework. It's basically an SDK which you can use to build bots, no matter if you are a .NET developer or JavaScript developer or even Java or Python developer. You can use that SDK to actually build your bots. You can do that on whatever platform you want to build your bots, so you don't need to have a Windows machine. You can do it on Mac or even on Linux, and therefore you're not bound to any kind of limits which Microsoft actually has come up with. On top of that, you have what they call the hosting platform for your bots, which is called the Azure Bot Service. And this kind of gives you the possibility to host your bot either within your Azure subscription, or you can also host your bot in Amazon AWS or even in your own data center, because a bot built by the Microsoft Bot Framework is just a web application you need to host somewhere. And of course, you can host that web application wherever you want to. But the Azure Bot Service is kind of the glue between your bot being hosted somewhere and the channels you want the users to use in order to interact with that bot. So the Azure Bot Service offers you certain capabilities in order to integrate different channels within your bot, so you can basically pick and choose between the channels they offer, like Microsoft Teams or Skype, but also third parties like Facebook Messenger, and or Microsoft actually takes care about the whole integration within those channels. So you don't need to actually create a ticket at Facebook saying, hey, I want to integrate a new app for your platform. The only thing you need to do when you use the Azure bot service is to get a new Facebook app page, get the Facebook app ID and Facebook app password, and that's it. Paste it into the Azure portal from your bot, and you're good to go. And you have your bot up and running within Facebook Messenger within a couple of minutes. So that's the cool thing about it. You don't need to take care of each and every piece within your complete bot platform, because some things are done by Microsoft. On top of that, as I've already mentioned, you got to use some kind of services which deliver intelligence in some sort. With Microsoft, in the Microsoft ecosystem, you have the cognitive services for that, which are grouped in certain areas like vision, where you can do computer vision, or you can do face detection, or what have you. Then you have certain services for speech, like speech to text or text to speech, or even speech translation in real time, which you can integrate. And you have some services for language, meaning language understanding, Q&A maker for managing knowledge bases, text analytics for example, detecting the sentiments of given input text, and so on and so forth. And on top of that, you don't need to start from scratch. You have a lot of samples and solution accelerators out there which you can use in order to start building your bots. We have some kind of guidelines in there, and the virtual assistant template, which is visible up here, basically is a complete bot project already pre-filled with data, so you can just download it, start Visual Studio or Visual Studio Code, click F5, and you have your bot up and running within a couple of minutes. And if any one of you has ever looked at the Microsoft Teams App Store, you will notice that there are a lot of bots in there, and most of them will be also built by the Microsoft Bot Framework, because that's the easiest way to integrate bots within services like Microsoft Teams in the Microsoft space. Good. What are bots? Bots basically are computer programs, as I said, and they are designed to have that conversation with another human being, of course, over the internet. The primary goal of bots should always be to solve the user's needs in the quickest and easiest way possible. So imagine you currently have some SharePoint environment on premises, and you have a lot of data and a lot of files in there, and if the search isn't working and configured correctly, users will have a hard time actually finding documents and searching for documents. So this could be a pain for users to actually search for documents in the various scenarios, because what they need to do is, first of all, check which site or site collection they need to navigate to, where the document libraries are stored. Then they need to find the document libraries, and within the document libraries, they need to actually search for the documents. If you compare that use case with the same use case, but coming from a bot perspective, the user actually just needs to tell the bot, hey, I need this document, or I need the documents, all documents for a certain category or for a certain metadata tag or what have you. And if the bot actually is integrated within your SharePoint environment or any other system, retrieving data from that system, the bot can actually respond fast with the correct documents, and the user saves some time and has some more time to do like innovative stuff or fun stuff or any other thing. Another fact is bots don't sleep, obviously, so they're 24/7 available for users, for end users to answer their questions, and therefore bots are usually quite common in that kind of customer service scenario, where you maybe have some kind of help desk for users, and of course, if the guys from the help desk, they will be glad if they don't need to actually provide users 100 times a day the answer to how can I change my password, because this can be easily handled by a bot as well. And the help desk employees will then have more time to do either the really sophisticated questions or hard tasks or hard support tickets, or they have some time for doing innovative stuff, for learning new stuff or any other thing. And especially where I'm coming from, users or people are mostly kind of have that kind of friction using some sort of AI service because they think that the computers will take over at some time, and will actually lead to the fact that they will be unemployed tomorrow in the worst case. And with introducing, let's say, a chatbot, which is some kind of lightweight AI service, you can actually take the fear out of those people, telling them, hey, this won't replace you, but it will actually be some kind of assistant for you to handle routine tasks and repetitive tasks, so that you have more time to do the fun stuff or the innovative stuff or the stuff which requires a human being to do. But this was kind of the general introduction. Let's dive a little bit deeper into what Microsoft offers in terms of building bots. So I've mentioned it earlier. You got the Microsoft Bot Framework, which is open source. You have a ton of public repos out there on GitHub. So if you could just go to github.com/Microsoft/botbuilder minus either.net or JS for JavaScript or Python or Java, you can take a look at them. But that's not all. You gotta they offer some CLI tools for managing all of the services from the CLI. You have a dedicated bot framework emulator to actually test and debug bots locally. We have your chat window locally running, so you can actually trace the whole conversation stack locally. You have an open source web chat control, which you can use to integrate within your public facing websites or even on SharePoint pages or any other services. And of course, you gotta have some documentations out there, and we have now nearly 70 samples which you can use, ranging from simple echo bots to really sophisticated bots with multiple dialogues or integrations into other services or even handoff scenarios and so on and so forth. And so the Microsoft Bot Framework actually can be categorized in 3 different layers. The first layer would be the users, which you actually, as a bot developer or bot architect, you can't control users, but users always communicate via various channels with your bot, and the nitty-gritty of the conversational AI platform and of your app is actually what you do within your bot, where you host your bot either on Azure, on premises, or any other cloud service provider, which SDK you're using. The cool thing about it is all of the SDKs share the same concepts and share the same implementation approaches. So you can build your bot today using C#, and you can build your bot tomorrow using JavaScript, and the concepts and the patterns are the same for both of them. Microsoft offers you a lot of pre-built patterns, like state management is already implemented for you, so you don't need to take care of that. Dialog management is another thing which is actually already implemented, and you just need to use some calling functionality to call another dialog. Same is true for rich attachments. If you want to build a bot who should be capable of delivering not only text outputs, but also work with cards or images or videos, this is all pre-built for you, and you don't actually need to develop the whole stuff on your own. You could just use what's already built for you. And of course, upon that layer, a bot is actually nothing more than a web application. The intelligence is coming from the cognitive services, and this is a set of right now 30 APIs which you can use and plug in within your bot to deliver certain intelligent services for your end users. So in terms of integrating the whole stuff, if you have already built your bot, then you can integrate your bot within various channels. and the objective of Microsoft is always to actually build your bot once and run it multiple times for multiple channels. Like you can build your bot once and then you just say, I want to have that bot running in Microsoft Teams, and I want to have it running on Facebook Messenger, and those two channels actually share the same bot. Of course, you would need to make sure that all of the functionality you're using within your bot, especially UI functionalities, are supported in all of the channels you want to use, because Microsoft Teams treats some UI functionalities like working with cards differently than Facebook Messenger does. So you need to take care of that little piece. But from a business logic perspective, you can actually use your bot on various platforms at the same time. And you have a lot of platforms and channels already supported, Microsoft ones and third parties, and the list gets longer and longer as they want to grow their channel integration platform as well. So you even have the possibility to integrate Amazon Alexa or even Google Assistant within the Microsoft Bot Framework to build a bot for your Amazon Alexa devices if you want to. Good. Before we actually jump into a demo, I want to kind of give you a quick overview of what we will be seeing later on with the Microsoft Composer. So basically, if you're using Microsoft Composer, you're not actually writing code anymore to build your bot, because you're using a graphical user interface to build your bot, but you need to have some certain knowledge about how development and patterns and concepts are working. So first of all, if you want to build a bot, you should definitely integrate some kind of language understanding into it. And what Microsoft offers is a service called Language Understanding Intelligence Service, which is one of the cognitive services I mentioned earlier. And this service brings you language understanding. And language understanding actually works that way that you define your intents. And per intent, you define certain utterances, so the examples of that intent. And Microsoft says 5 utterances per intent are enough to be able to train your language understanding service. So like in our case, or like in that case we have right here, we have 2 intents on the left side. Greeting is one of them, and book flight is another of them. And so you would need to find 5 sample phrases or 5 utterances per intent to make sure that your language understanding model can be trained and can be used. And in the past, you would need to go to a portal which was called Louis.ai for managing your language understanding applications and models. With the introduction of Microsoft Bot Framework Composer, you don't need to do that anymore, because this is integrated within Composer, and we'll see that later on as well. So you don't need to switch between portals anymore. You just have one portal, which is the Composer, where you can actually manage everything which is connected to your bot at a glance. The second thing, which we'll have a look on afterwards in the demo as well, is how to deal with not only language understanding, but also with language generation. Because you don't want to build a bot which always responds with the exact same phrase for a given input. Like if you're thinking about greeting, users will greet your bot, and the bot in the past, where we didn't have the language generation part integrated into the bot framework, would always greet the user back the same way, saying hi, for example. And with language generation, you can have that kind of markdown editor for managing your language generation pieces. And for instance, if the bot should actually greet the users, he could say hi, or he could say hello, or even more sophisticated based on the time of the day, he could say hi, good morning, or hi, good afternoon, or good evening, or what have you. So you bring a kind of more sophisticated response management within your bot to make it more human-alike, if you will. So that's another thing we'll see later on. And the last piece, which is kind of the kind of new approach for building bots is called adaptive dialogs, because in the past, if you already have built your bot using the Microsoft Bot Framework, building bots was always development work. So you needed to write code in order to build your bot, and what Microsoft actually strives for is to give not only developers the possibility to build bots, but everyone. With the use of Microsoft Bot Framework Composer, you use a pattern called adaptive dialogs, which is a kind of dynamically adjusted conversation management solution. So dialogues actually are written not in code but in JSON format, and this gives us the possibility to exchange certain pieces within a dialogue or even complete dialogues on runtime. So you don't need to redeploy your bot if you want to make a change. You just change the piece within the JSON file, and you're good to go basically upon saving. So the goal is to write less code and have the same kind of functionality within your bot development routine.
Hey,
So
Stefan,
yeah,
sorry to interrupt. A quick question as you were on the slide.
yeah.
Was the code on the language generation slide pseudocode or actually a language?
Actually, this is Markdown, and it's kind of pseudocode, but what Microsoft introduced is they have their own file formats for language generation. They call it .lg files, and they have their own file formats for language understanding, which are called .lu files, and the same is true for dialog. So they have .dialog files, and language generation and language understanding are basically Markdown files with certain rules in it. So intent names always start with a hashtag, followed by the uterances which start with a minus, for example, and then you can do basic operations in there as well, like basic if-else statements or for loops or any other thing to manipulate a certain pieces within your language generation files. I hope that answers the question.
I think it does. It does, at least for me. But yeah,
Okay.
I'll let you go on. Yes, we got a
Okay.
confirmation.
Great. Great. So it's basically marked on you're writing. Okay, good. This was it from the slide side of things. I want to jump into a demo, and I want to use the minutes we have left to actually build a bot using the Microsoft Bot Framework Composer. So every one of you can go to aka.ms/bfcomposer, which will bring you to a GitHub page where you can download the Composer. Right now, Composer is a solution which is running locally. You need to host it locally, but as we speak, Microsoft is actually trying to develop a more sophisticated solution to actually have that as a either web application or any other kind of platform you can use to actually build bots then. So I'm going to quit my slides, and I've already brought up my Composer right here. So if you go ahead and download the code from GitHub, and then you do the installation and start the server, you will end up having your Composer GUI over here, where you can actually get to know what Composer is. They also have certain examples up here, so you don't need to start from scratch. You can actually start with a given sample. For example, if you want to see how to build a bot using Q&A Maker for knowledge management and Lewis for language understanding, they have a dedicated sample up here, which is pre-built for you, which has some dialogues already attached to it, and you just need to run it locally and you're good to go. But we'll start from scratch because I want to give you a short overview of what Microsoft Composer actually offers. So we'll hit the New button, and then we'll leave the option Create from Scratch, and then select Next, and then we'll just need to give it a name. I want to build a bot which serves us with some weather data. So I call it WeatherBot, and I'll give it a description. and I'll click next, and the bot will actually be created for me. And this is your typical user interface when using Composer. So on the left-hand side, you have your menu where you can switch between design the whole flow, design your dialogues. You can also take a look at what responses you already entered for various dialogues. You can also see what user input types you're expecting for various dialogues. And you have a dedicated section for settings where you can store your Microsoft App IDs, your Microsoft App passwords, and your Lewis and Q&A specific keys. So I'll switch to design flow again, and upon creation, the composer has actually already created one dialog for us, which is the greeting dialog. And so the greeting dialog will be the first dialog which will be triggered when someone actually starts a conversation with our bot. So we have right here a for each loop, looping through all the members who have been added to a certain conversation. And then we'll just check if we already have had a conversation with that person. If not, we can send out a given, for example, response or a greeting message or whatever. So within Composer, you'll see you have all of the time you have the plus signs which you can click, where you can actually pick and choose from actions you want to integrate within your bot, like send a response. You can also ask a question, ranging from simple text input, but also sophisticated ones like asking for a file or attachment, or even for date or time. And you can also trigger certain login processes within your bot without actually writing any code. And that's the cool thing about it. So we'll go ahead and first of all pick the send response option up here, and you'll notice on the right side we have a kind of layout in here where it says send a response, and we need to actually now write our markdown language generation into our text input field. So I've already prepared a greeting for us. So I want to send each and every user who enters the conversation a short greeting message saying, hi, I'm a friendly bot that can help you with the weather, and so on and so forth. And this actually will then trigger the response for us. So right now we have just one dialogue in here, but we can also, but now we can even start the bot right here from the composer. So on the top right side, we have start bot. If we click that, the composer will actually spin up the bot on my local host, make sure that all the dialogues are translated into code. And if it's done, I have the button test in emulator up here. If I click that, the composer actually will open up the bot framework emulator I've mentioned earlier to actually test and debug bots locally. And so what will happen right now is that the emulator will connect to my locally running bot, and it should actually greet me with the message we have entered before. So I'll just go ahead and restart the conversation, and there it is. Hi, I'm a friendly bot that can help you with the weather. Try saying weather or forecast. So if I go back to my composer and I want to make use of the language generation piece of it, I can define another response in here saying, hey, we are in Vlad's webinar talking about the weather, for example. And if I now go ahead and say restart bot, you'll quickly notice that it just went on reloading the stuff. And then I go back to my emulator and restart the conversation. And please please be aware that I'm using certain development bits on my machine. So I have certain bugs in there which you will hardly ever face. So restart the conversation again. It says, hey, we're in Vlad's webinar, and it actually picks a random response each and every time I restart my conversation. So one time it's the first one, another time it's the second one, to bring that kind of human-like conversation bits and pieces in there.
Quick question for you, Stefan.
Yeah,
Sorry.
yeah.
Actually, questions. First of all, where do you configure the default language, for example, German, English, and so on?
So the the thing is, the composer is right now in public preview. So they're working on those kind of multilingual scenarios right now, because right now the default language is English. If you want to change that, you need to actually go to your settings page, and you'll see for the language understanding part, it's pre-filled with EN-US, and the offering region in terms of the Azure resources is also West US. So if you want to make use of, let's say, the EDE, you change the offering, you change the default language to the EDE, and then you can actually choose whatever offering region in terms of Azure resources you want to have. So from that point on, your bot will actually understand German if you start it, and speak German as well.
Awesome. And another quick question. Did you have to configure the connection with cognitive services separately?
So what you will see that later on, what you can do from the composer side of things is to use language understanding and Q&A right from composers. You don't need to do anything else except for creating the Azure services for Lewis and for Q&A Maker, but you don't need to configure anything else. If you want to integrate other cognitive services in there, you would need to actually create the services, and then the simplest thing, just call the API from right within Composer. I'll demo that later, how you can actually call other APIs or other services right within Composer without writing code.
Awesome. Thank you.
Good. So actually our bot is pretty simple. Uh, Upon here, we just have one dialog, one trigger. We can't do anything else with it. We want to enhance that. And as it's a weather bot, I want to actually get the weather from some services out there within my bot. So I'm going to go ahead and create a new dialog for that. So I click the new dialog button on the left-hand side. I give it a name. Let's say this is our get weather dialog. Give it a description. And then if I go ahead and select next, I have my dialog already created here. And what I can do from within here is I have the same trigger, begin dialog, and this is empty right now. But in order to make the user aware that the user can check the weather with our bot, we'll send a simple response saying, let's check the weather, or I'll check the weather for you, for example. And next up, the dialogues are basically not connected to each other. So we have the main dialogue, which is the first dialogue to be used within the conversation. And then we have the get weather dialogue. And in order to use our get weather dialogue whenever someone wants to know something about the weather, we need to go ahead to our main dialogue. And there we have certain what Microsoft calls recognizer types for language understanding. And this is on default set to none. You can use Lewis for language understanding, or you can use regular expressions. And right now we want to go ahead with Lewis, of course, because we want to have that language understanding part within Composer, saying, okay, if someone asks for the weather, we want to make use of Lewis to actually derive the intent from the input question and then route to a given dialogue within here. And if we want to do that, we can go ahead and go back to our greeting, and then, for instance, say after someone has been greeted, we begin a new dialogue. And we select the name get weather. Sorry, forgot something else, because we need to have some kind of trigger as well before we can actually begin our new dialogue. So we need to create a new trigger event within our main dialog saying if an intent, for instance, is recognized, we want to have that trigger running. So create a trigger. The type of that trigger is an intent, which has been recognized by our Lewis model, and we give it a name. Let's say this is the get weather trigger within our Lewis dialog, and then what we can do right within Composer is to define our language understanding model and the sample phrases in here. So I'll go ahead and add some sample phrases in here, like what's the weather, how is the weather, will it be raining, or even just weather as a phrase. We'll submit that, and now we can actually, within that given trigger, begin a new dialog, and the dialog is our get weather dialog, of course. So I'm going to delete that one again because this is not necessary anymore. So within our trigger get weather, we see at a glance what are the expected inputs or the expected responses from users to make sure that our intent, our language understanding intent get weather will be triggered. For instance, what is the weather? How is the weather? Will it be raining? And so on and so forth. So if I now go ahead and restart my bot, you will notice something that it wants to actually publish a Lewis model, a model for language understanding. So I need to provide it with a key. This key is actually bound to my Azure subscription, so I have a primary key for Lewis in there. It will create a new Lewis app with a default language ENUS. If you want to have another language supported, you just need to change that within your settings. Click OK. Composer will actually now reach out to Lewis, to the language understanding cognitive service, create a new model, within that model, create a new intent called get weather, and give it and pass it along some uterances. And this took some seconds, and the bot has been finished reloading. If I now go ahead to my emulator again, and if I test it, I say, what is the weather? It should be triggering that new get weather trigger within Lewis, and you see it on the right hand side. It says Lewis trace, so we can even take a look at what Lewis actually gave us back as a score, because we got back 0.98, which is 89%, 98% sure that what is the weather belongs to the intent get weather. So that's pretty good. And we've right now connected one dialog to another dialog using the language understanding bits and pieces in there. So what you can do as well, and what's really easy to do within Composer is if you are in that weather dialog, you need certain metadata from your end users to make sure that you can get the weather with the correct location, for example. So for that, we go ahead, and after sending the response, the first response, messaging the user, hey, I'm going to check the weather for you. We want to ask a question, and we want some kind of user input in form of a text. So we go ahead, select text input, and right now what we need, for example, to check the weather is the zip code, obviously. So we go ahead and say, what is your zip code? Or give me your zip, please. And as we expect the text input field, we need to also store that given input from the user somewhere. So we switch to user input, to the user input tab within our text input, and there we have the possibility to fill out certain properties. Properties are more or less variables within our bot, but we don't need to write code for that. We don't need to instantiate variables. We just need to give the variable or the property a certain name. So in our case, It's the user.zip code, which we can then refer on later on in our dialog as well. And we can do certain operations on that as well. So we want to trim it in case someone enters a blank space to make sure that we only have the actual value within our property stored. What we also can do is work with certain validation rules, for instance, and give back certain prompt types. So for example, if the prompt hasn't been recognized, we give back an error message, if you will. Sorry, I didn't understand whatever the user entered. Please specify a zip code in the form 12345. And if the input has been delivered invalid, we can do the same. So sorry, this value is not valid. I'm looking for a 5-digit number as a zip code. And here again, you can make use of language generation as well to make the conversation more sophisticated. What we also want to do is to set a default value. If, for example, no one, the user hasn't entered the value or just click next or what have you, we can actually enter the default value. And this is one question to you, Vlad. Do you know that zip code by heart?
I don't know it by heart, but I'll have a feeling it's the Microsoft HQ.
Yeah, that's
yes.
So we enter the zip code from Redmond as a default value in there, and basically we're good to go asking the questions. But now that we have the zip code, we need to do something with it. So we need to create another action within our dialog in order to get the actual weather forecast for that specific zip code. So we go ahead, click on the plus sign, and then we go to access external resources. And there you have the possibility to create an HTTP request, but you can also go to other services or connect to or make an OAuth login process or begin a new skill dialog from another bot framework built bot. So we select send an HTTP request, and I've prepared or wasn't me, but some Microsoft folks have prepared some APIs for demo purposes. So we select the HTTP method, which is in our case a get method, and then we insert the URL. The URL is an Azure website, an Azure function, where we actually pass the user.zip code. Remember, this was the property we filled out within our user input field into that URL query parameter, so that we actually can connect our user zip code with the API to deliver the correct zip code to the API to get a correct response back. And what we want to do is we want to save the response we get from the API in another property. So as a result property, we fill in, for instance, dialog.api underscore response to actually retrieve the response from the API, save it somewhere to have it later on for certain conditions and for certain outputs as well. So we have now created the send HTTP request action. Now, what we want to do is to actually check if the HTTP request has been executed correctly. So we go ahead and create a new condition in form of an if-else. And within that condition, we say the dialog.api response status code. So the status code we get back from our API should be 200, meaning HTTP OK. If that's true, we have two routes, one for true, one for false. If that's true, we actually want to set a new property, and we call the property dialog.weather. And the value of that property should be what we get back from our API. So it's dialog.api underscore response dot content. So this is the content we get back from our API. And then if we have that if we have that response from our API, we can send it back to our users via the same send response again. So from the language generation bits and pieces, we say the weather is dialog.weather.weather. So the property we set in the task before, referring to the weather, and the temperature is dialog.weather.temp. So this is what we get back from our API with in degrees, and this is actually what we can send the users back to. In terms of if the HTTP request fails, we want to notify the user, of course. So we send another response in our false statement saying, I got an error, to actually just notify the user that there was something happening which was not on purpose. So that's basically it from the build side of things. We can go ahead and restart our bot again. So the new dialog will be created. All of the HTTP bits and pieces will be attached to our dialog. It's already finished, so we'll go back to our bot framework emulator and now say, what's the weather, to be routed to our get weather dialog. And then we want to get the weather, the current weather for Redmond. So we paste in our zip code for Redmond, and now we get back the weather is rain and the temperature is 40 degrees. So the weather is rain is not that good of a sentence. So in order to overcome that issue, we actually want to tweak that a little bit because the far more better approach would be it's rainy or it's currently raining and not the weather is rain because that actually doesn't fit quite. So we go back to our composer, and there we have on the left-hand side the bot responses, which will actually list all the responses we have inserted into our composer. And there we have the possibility to not only view that, but we can also edit that. And I've prepared a little snippet before saying describe weather. So we describe a certain property called weather. And if the weather dot weather, so the value for the weather is, for example, clouds, we say it is cloudy. For rain, we say it is raining. For smoke, we say there is smoke in the air, to make that the whole conversation more sophisticated. And in order to change that, again, within our bot responses, we'll go ahead and exit the edit mode again, go back to our designer, to our get weather dialog, and there we search for the response we have sent currently, saying the weather is dialog.weather.weather. And now we actually want to go ahead and say describe weather. So we actually use a certain function within there, saying describe the weather, and by executing that function, we tell the bot to actually make use of the language generation models and pieces we've copied in there right away, and then give out the correct response. So if I restart my bot now, and I'll just go ahead and copy my zip code again. I'll restart the conversation.
You know
And
it's Washington, so it's probably going to be rainy. I'm just saying.
Yeah. So what is the weather? Again, we are transferred to the weather dialog, given the zip code, and now it says it's raining and the temperature is 40 degrees, and not it's rain, because that doesn't make a lot of sense in there. But until now, as you've seen, we just work with simple text inputs. I advise everyone to not only focus on text only, but also work with certain cards or certain images, for example. because then the whole conversation is more sophisticated if you work with images or if you work with buttons instead of sending just text inputs and outputs, because users are used to send images back and forth or click on buttons here and there, and this kind of makes the whole conversation a bit more sophisticated. So if I go ahead and go back to my composer within the get weather dialog, I actually don't want to make use of text only up here, but I want to send a card, and we have what Microsoft calls a thumbnail card, which you can use right away. And a thumbnail card consists of a title, consists of a text, and consists of an image. So if you change our response from text only to a thumbnail card and restart the bot again, you'll quickly notice if I restart the conversation in my emulator, that we won't get just the text. It is raining and the temperature is 40 degrees, but we'll get a more sophisticated way of telling people what's going on in Redmond right now. So, and I'll leave that typo in there to show you that language understanding is working. So what's the HW weather? It's also working. Insert the zip code again, and there we have our thumbnail card.
Nice.
And I'll just switch my theme to light, and you'll see that we actually have some text up here. We have an image here, and the weather details are shown here as well. So that's basically it. From a starting point of view, you've seen in 30 minutes we've built a sophisticated bot using an API for parsing weather information without writing actual code. So I would encourage any one of you, although the composer is still in preview, check it out, download the tool, check out the samples they have out there to actually get the bot development up and running quite quickly. So if you have any questions, Vlad.
I have 3 questions for you, Stephan, and we seem to have about 2 minutes left. So first one, and this is actually really interesting. Do you always have to start testing conversations from the beginning, or can you jump to a certain part of the conversation?
I don't know if you've seen it, but what the newest, I can't demo it right now, but the newest bot framework emulator has a feature called restart conversation at that specific response. So you'll end up having buttons up here where you can just click that button and the whole conversation will be played back in a transcript mode, and then you have the complete conversation restarted again until that point.
Nice. Another question. What is the licensing cost and or monthly charges for using the Microsoft services?
So that's quite dependent on which services you're using. So if you're just in a development phase and you host your bot locally and test it locally, and you only use, for instance, Lewis, I guess all of the cognitive services, they offer a free tier, so you can make use of all of the cognitive services in a free tier approach. And from what we experienced with customers where we have built bots is you need to calculate roughly around $150 to $200 a month for a sophisticated bot running in Azure, connected to Lewis, connected to any several other cognitive services, and have that kind of always-on features in Azure as well. So something between $150 and $200, I would say.
Awesome. Okay, so a few questions on how do you publish the bot to SharePoint or Teams?
So first of all, within Composer, you need to actually go to your settings, and there you have the publish option, which consists of creating, first of all, the Azure resources necessary for your bot, meaning the Azure web app, the app service plan, the resource groups, and so on and so forth. And then you can publish your code to those Azure web apps. And second of all, if you have published your bot, and I'll quickly demo that in my Azure portal, If you have already published your bot within your Azure portal and you have it up and running, you will end up having a UI like I have here, and then you just pick the channels you want to make your bot be connected to. For instance, Microsoft Teams. This is a matter of 2 seconds. You just need to click Teams, the icon, click Save, and then you can actually jump right into the conversation within the bot in Teams. It will open up the either client or web app of Teams, and then you can start having a conversation with your bot right within Teams. So that's a matter of minutes, depending on the channels. For SharePoint, you need to make use of either SharePoint Framework web parts, where you just connect your SharePoint Framework web part via direct line, where you get a key with your Azure bot service to establish the communication.
Awesome. Okay, so let me see. I guess for after we can share, I can see there's a few questions on that. Maybe a link or something that we're going to send in the resources on how people can get started to publish it to SharePoint and Teams. Do you
Sure,
have any resources? Yeah.
there's a sample web part out there, so we can share that. Yeah.
Okay, perfect. Can you also have a speech conversation, so voice recognition, text-to-speech, and so on?
Sure. So what you can do is you can integrate either the Azure Speech services for speech to text and text to speech. So you build your bot as we've built it with Composer the last couple of minutes, and then you just say each and every message from a user using voice should be translated into text, then be routed to our bot. The bot actually kicks in and does the whole business logic, sends back the responses in text, and then we'll pick up the text and make text to speech, and then answer the questions from the users via speech again. So that's also possible, yeah.
Awesome. And one last question, as I see we're 5 minutes over time, but people have stayed, so thank you guys. Thank you everybody very much. Can you test in Teams in developer mode so you don't have to pay to kind of run it as a trial or a POC, or you need to get it published and start paying to test it in Teams?
You don't need to publish your bot to Azure. What you can use is, for instance, ngrok is a tunneling software, so you can run your bot locally and connect it to Teams via that API tunnel, where you get the public URL, and then within your Teams app manifest, you just refer to that public URL where your bot is running. So ngrok could be a problem solver for that.
Awesome. Well, thank you very much, everybody, for attending, everybody that asked questions. I think we got to all of them. And thank you very much, Stephan, for taking the time and sharing your knowledge with the community. It was really, really interesting what you can do, especially for somebody that doesn't code a lot like me. Really cool what Microsoft has put out.
True. Thanks. Thanks for inviting.
And for everybody, again, we will send resources as well as the recording by end of day tomorrow. So if you ever want to rewatch it and some of the links that Stephan shared, you'll have access to all of them. So thank you very much, everybody, and have a great end of the week.